I think so. This being a practice interview, we'll still try and do it in the fashion that actual interviews happen,
Hmm.
and but I'll make it more casual so that if you need hints or if you need more, uh, feel more than happy to ask me questions. Just because it's a practice interview, you have more luxury that way. Okay.
Okay.
So yeah, let's start with introducing ourselves. I'll go first, and I'll give you a few minutes to let you talk about some of your recent work, any particular project that you would like to talk about, whatever interests you. Um, and I think this is a coding style interview that you would like to do.
Um, Coding style interview?
I mean, is this a basic standard coding algorithm data structures interview that you are practicing, right?
Yes, absolutely.
Right. Okay. Great. So, Peter, I have been in the industry for 14 years now,
Okay.
and have worked across few companies, working on services, APIs. Um, Used to do things in the front end before, now more of a back end guy.
Mm.
Looked at distributed systems, and yeah, enjoy solving larger problems with more simplicity. Um,
Mm.
so that's why what I focus on now. Um, yeah.
Okay.
How about you?
Yeah, so I'm a rising junior in college studying computer science. I took a gap year this year, so I'm going back to school in September. But over
Okay.
this gap year, I worked as a front end intern
Okay.
for a physical security startup in California.
Okay.
And so I sort of delved uh, deep into front end only, and don't have much exposure to the back end or distributed systems or things like that.
Sure.
Although
Yeah.
I do want to move into that field out of college.
Sure. Um, Fair enough. Um, is Do you have a preferred language of choice that you would like to
Yeah, is
practice
Python
on?
2 okay?
Sure, I'm fine.
Okay.
I haven't coded much in Python, but I'm more than happy to understand what you write the code in.
Okay.
It's Yeah, I'm still learning. Um, um, any particular problem that you would like to solve, or focus on areas of the problems, like specifically string problems related to arrays or data structures in particular?
Just whatever you think is okay.
Okay. All right. So, have you heard of the stocks buying and selling problem?
I have, yes.
Okay. Um, then let's skip that. So you would have already practiced it.
Mhm.
Um, let's go by. Do you understand what a LRU cache is?
Yes, I do.
Do
Uh,
you know how to code for it?
um, I I I can try.
Okay. So Let so why don't you first tell me what's an LRU cache? I'll give you a minute, and then I'll actually put in what you need to do so that
Okay.
yeah, you understand. Okay.
So I think an LRU cache is a least recently used, and so it's essentially a store of data that has a certain kind of capacity, and you're able to introduce elements and store it in that data structure. And if you look for the same value in that data structure, then it can be immediately returned. Um, Whereas if the value is not in the cache, then you won't be able to find the value.
Right. What happens if the capacity is full?
Then the least recently used element is ejected, and the new element is inserted into the cache.
Okay, great, fantastic. I think you know the you know the cache as such. Let's try and code for it. I'll put in the problem statement here. Let's how do
It should be command slash.
control slash, yeah.
Yeah.
Okay. Yeah. So what you need to do is it's basically an LRU cache. You need to implement using a data structure, and there are basically two methods that you have to implement: get and put. Get being if the key of the element is present, then you get me the value for it, and put is if the key is not present, you insert the record, and if it is already present, then you have to basically eject it and then put it back again so that it becomes the most recently used one. Okay.
Okay, so.
And I'll give you a few examples. For example, I had the problem in Java, but I'm basically a Java coder
Yeah, sure.
who writes code in some other languages too, like C or C++. So that's fine. So essentially what you need to do is, so let's say if you have a cache, you put the first element 1, 2. For the simplicity of this question, let's just take in that the key and values are the same. So if you say put in a key of 1, the value output should be 1. If the key is 2, value of that is 2. So it's just a numeric values and keys. Okay. And at this point, at this juncture, if you have inserted 1 and 2, if you retrieve the most recent one, you will get 1 over here in this line. And then you go ahead and put 3. And then next time when you get the output, get 2, it should return you 2, and then make that as the most recently used. Okay. So is the problem clear?
Yes, it is.
Okay, great. Yeah, go ahead with however you want to start off with, and I'll also tell you that if we get across this problem faster, then we'll spend more time on another problem.
Okay, great.
Yeah.
So just to clarify, if the element is not in the cache, then we when we try to get that element, then we should just return none.
Yeah, return none, return -1, whatever feels good. I made it -1 just because we only deal with integers.
Okay, I see.
But
okay.
yeah.
So I think the general approach is so we can have a hash table that
Okay.
That points to a node. It's part of the linked list.
Okay.
And so that's what happens when we do object.put11.
Okay.
And so node 1 is a linked list, and you try to put in 2. First, you check that the hash table is smaller than the max capacity. And I guess you put it behind this node 2, behind the node 1. I think it'd be better if we put it before node 1.
My quick question over here. Pardon my understanding of if this is very specific to Python, but why are you using hash table with the value being a linked list node?
So I think this would just store a reference to this pointer, or it'd be a pointer to this node, or this one rather.
Let's say we are just dealing with integers. I mean, very basic. There are no objects much, and we don't need to take care of the pointers or anything. If it's a very simple numeric value.
Okay.
I mean, yeah.
Yeah, that makes sense. So let's start from the beginning. So if we have 1, then we add the 1 to the cache, and then we put 2, but we're gonna have to somehow keep track of which one was least recently used. So
what is the data structure in Python that does this?
A dictionary.
Yeah.
So 1 is the key and this 1 is the value.
Sure.
I think we do need a linked list to sort of I'm thinking that we need a linked list to keep track of the order of how these were added to our dictionary. Because so first it's 1, that's the most recent. And then when we add,
dictionary maintain the order of insertion?
Yes, dictionary does.
So if it does maintain the order of insertion, then do you need any other data structure to keep a track of the order?
Actually, I don't think that the Python dictionary keeps track of order.
Probably maybe in the, that's a bit strange with Python is that they have, I don't know what version of Python is running right now, but I can Google it up, but I think the latest one does it, Python 2 point something or 3, Python 3 maybe.
Let me just quickly try it then.
Sure. Go ahead.
Okay, we have a dictionary.
Yeah, and if you need to Google up something, I'm okay with it.
Okay.
Yeah, and usually in the interviews also people are usually okay. I mean, you can ask them.
Okay. Yeah, it doesn't seem to store the order because it should have printed B and A first, but it printed A and B.
Can you try adding some more so that I'm just saying if it maintains the reverse order? I mean, either way, if Python key does something.
I think it sorts it by like alphabetically. Oh, interesting.
So
Why is this?
ACB. Okay, so there is no order. Okay, that's
Okay,
fine. A, B, C. Yeah, there is no order as
yeah.
such maintained. That's fine.
Mhm.
Yeah, quickly, can I switch you to Python 3 and let's try this?
Sure.
I think I just googled it up. So, can you try running this one more time?
Mhm. Uh,
Are you still there?
oh yes. Can you see what I'm doing?
Actually, no.
Oh,
Oh,
oops.
sorry. What screen?
Sorry. Can you see me? Just uncomment this.
Yeah, yeah, you commented that out. Yeah.
Okay, cool.
Okay. Yeah, let's try this.
Okay, great.
VAMA.
So there seems to be
Yeah.
order. Okay, awesome.
Yeah.
Then if the dictionary maintains order, then I think we can simply put 1 and then put 2. Which means okay. So if the 2 is added after the 1, okay, and then when we get 1, we just simply remove it and then add it again. So
Yes.
that was line 13, and then for line 14, we add it to the end. And then we try to get 2, and then we put 4. Oh, oops.
Yeah, that's right.
Right, so it was at 1, 2, and then we got 1, right?
Yeah.
And then now we want to put 3, so we simply
Yeah.
delete the first entry and then add 3, 3. And then,
Yeah, if the capacity is 2, yes. Okay.
right.
Yeah.
And then we try to get 2, but it doesn't exist, so we can simply
Right.
give them -1. And then we put 4. 1 is the least recently used. And then we get 1, which is also -1.
Right.
So I think that's the general approach.
Right.
Is it okay if I begin to implement that?
Yes, please. Go ahead with the implementation.
Okay. This should be a class, LRU Cache. So this has a initializer and a put. And a get. So this is going to need a hash, which is just going to be a dictionary. Maybe this can have a the given max capacity. Now, when you put the value, you want to do the length of self.cache is less than the self.max capacity, and you're just free to append the key value to our cache. So you do self.cache at key value. Otherwise, you need to remove the first entry from our cache. So you need to delete, well, let's figure out what the first key is first. Keys at 0. Once you figure out the first cache, you can do delete self.cache at first key. And after deleting that first entry, you're free to add to that dictionary the key value. So if there's a successful put, should we just return true? Does it matter what we return after the put?
No, it doesn't matter what you return after the put.
Okay, we'll just return.
Let's just put be void or whatever.
Okay. So for the get, you can simply do value is in self.cache, and you want to to get the result. We want to get what that value actually is. I think this should be more appropriately named, which is key.
Mm-hmm.
So we're going to return that result at the end, but before we do that, we have to delete self.cache at the key, and then add it again. Return result. The key is not in self.cache, and return -1. So just to make sure that we're doing this correctly, just run through the example input again.
Okay.
So we create a new LRU cache with max capacity of 2, and when we put in 1, 1, length of self.cache is 0, and 0 is definitely less than 2, so we can add in the 1, 1. We can also do that for 2, 2.
Mm-hmm.
So at that point, we're going to have something. The self.cache is going to be 1, 1 and 2, 2. And we try to get 1. 1 is in the self.cache, so we get the value, delete that, and then add it again. And then we just returned 1.
Right.
And then we put 3. So we're at max capacity. So we get the first key, remove it, and then add 3, 3.
Mm-hmm.
And then we try to get a non-existent 2. So we just simply return -1, and then we put 4, and we return -1 when we try to get 1. So I think this should work.
Is there a use case where it won't work?
Mm.
I mean, can you see breaking your code for a use case?
Mm. So, okay, let's go through this maybe function by function. For the put, for each, as long as the length of self.cache is less than the max capacity, we add it to our cache. Otherwise, we
Okay, so let's say at line number 12,
mhm.
I change this to say this.
Yeah. So then we would enter this condition, this else.
Why?
Or rather, we would enter this because the length is 1 so far.
Yeah.
And then,
What would happen if you try and put the same key value again in the dictionary?
right. It wouldn't update the least, it wouldn't update the most recently used. So
Sorry, you said it will or it would or it wouldn't?
it would not update the most recently used. So to explain,
Mm-hmm.
if we had a 1-1 and hypothetically we had a 3-3 in there, and we put in another 1-1, then this should actually move this up to the front, but it doesn't do that right now, I think.
That's correct. That's true. If you increase the capacity, you would have done that use case. But in this case, if the capacity is just 2 and you don't have this, it's basically there is just one element in it, and your capacity is still less than the max capacity, and you would try and insert that again. So it should actually eject this and insert it back in again. So that step of ejecting after line number 32 is, I believe, it's missing.
Okay, so
what you explained is the same, is the same thing, but yeah, I'm talking in capacity of 2.
Okay.
Yeah.
So just to repeat what you said, you're sort of saying that if you try to enter like an existing key, then you should eject this and then add it again, right?
Right.
Okay, that makes sense.
Yeah.
I think in well, my thinking is if you already have the key, then I think this would just like update the value to whatever you try to put in, and it wouldn't increase the length of the cache. Right?
It would update the value and it will not change the length of the cache. Okay, let's go by the example. Let's go by the example that you were talking about when you were breaking the use case, which is so let's say if the capacity is 3, and let's go that we had 2 here and 2 here. So you had 1 and 1 inserted, and after that you will have 2 and 2 inserted. When you do line number 13, you would get the value of 1. It will remove it and put it after on line 22. Now when you get 3 and 3, you would insert that, right?
Mm-hmm.
Let's say I add one another line over here as let's say we do um, so let's say we do this, and instead of 3 3 I say 1 1.
I see. So you're saying this does
Yeah.
not move to the front like it should.
Correct, because you still have when you're trying to put in 1 1, you have actually, well, in this case, you would do is it would remove the first element because it is
Mm-hmm.
over the capacity,
Mm-hmm.
and then it is going to insert 1 1,
Right, which is a problem.
right? So now you have duplicates
Mm-hmm.
over here.
Yeah. So we need to add um, another conditional if key in self.cache. Um, read self.cache at key, and then you can add it to the cache.
Right, and that is for the case when it is within the capacity.
Mm, right.
And if it is, let's see, if it hits the capacity, in that case, you still retrieve the first key and delete the first key and then
Mm-hmm.
put it back again, which you will still get, then you will still have the duplicates if you, so what you're doing in the if condition should also be done in the else condition, right?
So
So
if we had, yeah.
So, with let's go one time more. 11
Mm-hmm.
and line number 12, you have 1 and 2,
Mm-hmm.
and at line number 13, you would retrieve 1
But
and put
this
it,
wouldn't be
yeah,
here, right?
mhm.
Right.
Yes, right. So at line number 13, you would um, get 1 and put it back again in the top, right?
Mm-hmm.
Which would mean interchange line 22 and 23.
Right.
Right. Now on line 14, you would put 3 back, 3 in. So because you still have capacity, so you will put 3,
Mm-hmm.
right?
Yeah.
Now come to line 15, you have to put 1 and 1. Now,
Right.
can you put 1 and 1? Because you still, now you have in the else condition, else block.
Right.
So going by the code, you will retrieve 2, 2 and insert a duplicate.
Mm. So we would need to do if key in self.cache, wait, self.cache at key. And so we would delete this 1, 1, and then also delete, well, actually, I think this would come after. So we would delete the least recently used. We would also delete this 1, 1, and then we would put it at the front.
But why did you delete 2, 2 then? So 2, 2 is now missing.
So it used to be 1, 1, 2, 2,
3, 3.
right, 3, 3.
Mm-hmm. Yeah.
Ah, I see.
So what should have been the output? The actual at the end of this step, your output should be 1 1.
3 3 1. Well, it should be 2 2 3 3 1 1, right?
Right. Yeah.
So you should only delete the least recently used. Um, so we're trying to put 1 1 back in. If it's already in there, then just delete it and then do self.cache key equals value and then just return. Maybe we can have an else statement. So if the key is not in the cache, then delete the first one. And then add the key, add the value at that key.
So can we go through the use case one more time with
Yeah.
the code change that you may want?
Right.
Yeah.
So in the beginning, self.cache is empty. And we add 1 1, and we add 2 2, and then we change these. And now we try to put in 3 3. So when you put in 1 1 again, you see that the key is already in the self.cache. So we remove.
But you won't come into the if condition because you have already hitting a capacity of 3. So now when you try to put 1 1, you won't come to line 45 because you have the cache is no more less than the max capacity. Right? We change the max capacity over here to 3.
Right.
So if the max capacity is now 3, you won't come here anymore, right? You will go into the else block. Right? What is the capacity right now with the current state of the self cache?
It's 3. So we will go into this else.
Yes. Now when I try to put 1 1, what happens?
We see that the key is in the self.cache, and we delete it.
Right.
And then we add it back, I think.
Right.
Yeah, I think this is a little bit messy, but maybe I wonder if there's a cleaner way to write this.
I mean, sure. I think this does the job. But yeah, you can clean it up by if you reverse the conditions if and else. If you always think that when you try to put a key and value in the dictionary, if you always try and check for its existence and then delete and add it back again, that takes care of the first thing. And then you can look at the capacity part. So, and then there are a few common code lines that can be, taken out and separated. But sure. Okay, good. Yeah. This this should work. Good job. Um, Great. All right, let's do one another problem then.
Okay.
Uh, so I'll give you here. So I want so given an input, I would like you to give me an output where you're given. So this is an array of strings, and you have to give me the largest common prefix among the strings in the array.
Hmm.
Have you seen this problem before?
I have not.
Okay. So this is one example. The other example will be um, this. In this,
Hmm.
there are three inputs: dog, race, car, car. So there is nothing common. So there is no common prefix. In
Hmm.
this, it's flower, flow, flight. The common is FL, even though FLOW is common between these two, but it's not common with this. So the common largest prefix is FL.
Okay.
Okay. Um, yeah. So sure. So tell me if you,
Um,
yeah, any questions?
are there always three inputs, or can there be any number of
I
inputs?
any number of inputs can be five, can be 10, can be
Okay.
20. Yeah.
And what should we do if there's zero input? Just return empty string, maybe?
So if the input is if they if the input is let's say this, then yeah, just return there is you can return a negative or a false, or there is no, just an error statement.
Okay.
Yeah. Or if input as anything like this, and then you have cat and cartoon, then even then the output has to be empty because there is nothing common.
Right.
So this should give you this. You can return
Okay.
a false here, or just an error message.
Hmm.
Yeah, yeah, but yeah. So these are the edge cases that we can look at. Sure.
Let's see. So I'm thinking maybe we can iterate through each. We can iterate from 0 to the length of the minimum string, the minimum length string, and also have a for loop that goes through each string. And if any of the characters are different from one another, then you can return. And once you have the largest sort of index where everything is the same, then you can take any of the strings and go from 0 to, say, I.
So you said you will start with reading from zero to the minimum. Uh, what
Length.
is the first thing that you would do? Minimum length string, zero to minimum length string. How would you know the minimum length string?
So we can go, we can do a simple pass through each word and
You
find
mean
the
each
minimum
string
length.
in the array?
Right.
Okay. Okay.
Uh, and so after we found that minimum length, we can go from I to that length.
Once you find the minimum length string, you would then
Oh,
go from.
sorry.
Uh,
Not the minimum length string, but rather the minimum length.
okay. So let's say in the first. example, the minimum length is 4.
Right.
So you will go from 0 to 4.
Right.
Okay.
And within that iteration, we do a inner for loop, and we go through each word, each string of the array, and we check that each character is the same.
Okay.
And if they're not the same, then we can break out.
I see. So if you're saying that in the first example it's 4, so you for the I being 4, you would check for the character of the first string, compare it with the second string, third string, and so on for how many ever strings there are in the array, right?
Right. Exactly.
Um, okay. So what if in that case, so this is a 3 string array. What if the input has, um, if this has, let's say, everything matching in it, but somewhere 1001th string is actually empty.
Hmm.
What would you do then?
So since we know that the minimum length is 0, it would actually make no passes.
Okay.
And at the end, we can return 0, because the only case that it wouldn't break is,
Right. Okay.
yeah.
Mm, okay. Yeah, I think that sounds right. That sounds right. Can I, do you know how would the complexity of this um, solution be?
Yeah, so I think it would be n times m, where n is the length of the shortest string, and m
Mm-hmm.
would be the number of strings in the array.
Okay. And then you also have n plus nm, okay, because you will loop through the array on the first pass
Right.
to find the minimum length of the string. Okay.
Hmm.
Uh, sure. Uh, let's see, what would I want you to do? Um, can you just code me the function where, let's say you have the smallest string and you would like to find out the largest prefix. So just code me that function.
Okay,
Yeah.
so assume that we already have the smallest length.
Yeah.
Okay. Find largest prefix. So something like that.
Smallest length. Yeah.
Okay. I want to go for I in range 0 to smallest length. Mm, see. I also want to do for string in words. Um, so we want all of the strings at index I to be, say, words at 0 at I,
Mm-hmm.
right?
Right.
So if string at I is not equal to char, then we can break out.
String. Okay.
And so I think in Python, the I actually remains the element inside, with the index inside here.
Uh-huh.
I think we can just simply do words at 0, from 0 to I. So let's see, if we had, quickly just test it.
Sure.
We had flower, flow, flight. Let's just take this one out because I don't think that will matter that much. So we go from 0 to 4. So chart is F. For string in words, if string at I isn't equal to F, then break. So we're at index 1 when we do L, we're at index 2 when we do O, we're at index 3 when we look at W. And so since all the words are valid, I will stop at 3, index 3, I believe.
Okay.
And so we want to take the words, the first word from 0 to 3 plus 1, because this is
Sure.
exclusive, I think. 0, 1,
Right.
2.
Now, just add the word flight back in again.
Mm-hmm.
And so now you have iterated over flower and flow,
Mm-hmm.
but when you come to the word flight, your index has to stop at F and L. So how do you stop that?
Yeah, so we would first do I equals 0, so everything is fine. I equals
Right.
1, everything is fine. And then we're at
Right.
index I, that's 2. And so if we go from 0 to 3 on flower,
So I is equal to 2 right now, and
right. And so we would return FLO, which is incorrect. Huh. So maybe it should be I. I'm not sure.
yeah.
If we do flower and flow, I'm not sure if the I reaches 4 at the end. But
If you are,
yeah.
if it increments it, so if I starts from 0, it doesn't matter. I mean, you can test it out. So if it doesn't matter, if I starts from 0, you'll just have to check it in Python. If it starts from 0, then you do a length minus 1, and if it starts from 1, just then just take the value of I, whatever the index is.
Right.
So yeah. Is there something in Python which would say given a string, given two strings, is there a string library that would tell you if a string is a prefix or suffix of a particular string?
I don't think so. Maybe you can do.
Okay. Yeah, I don't know, so I was just asking. So, if you, oh yeah, okay.
But it doesn't guarantee that it's a prefix, I think.
Yeah. So if you think something in this in these lines, then that might run things a bit faster. Is, let's say you have the smallest length word, and if you take in the smallest length word and start putting it against the rest of the words and see if the smallest length word is a prefix of the other word. If not, then decrement the smallest word by one character and then check for the prefix, or decrement it one more time, check for the prefix.
Mm.
So that way you always will have the smallest common prefix to start off with. What I'm by that I mean is, so between these two, flow will always be the smallest prefix. But if you go with these three, FL becomes the smallest prefix. Let's say you go with these four, F becomes the smallest prefix.
Mm-hmm.
So that way, if you have something over here already empty, you would it would just return you that there is no more smallest prefix,
I see.
right? So just another thought, but what you're doing is also one way to do it. Uh, you can look at it in another way as well.
Mm-hmm.
Okay, I think we are almost at the end of the interview with 4 minutes remaining. Yeah, I would let you ask any questions you have, anything.
Yeah, so this is not so much about the interview, but just about career progression in general. Is that okay?
Sure.
So how did you begin learning distributed systems? Is it like, did you read books or go to college for it?
No, actually, so I think there wasn't much of distributed systems when I actually started off. It was more of jumping into the work and then handling issues,
Mm.
and then slowly with some experience you start diving into you start from a smaller module and then you get into biggest components, and then you start saying that okay, fine, I think I can understand how this whole system works.
I
So it is starting from a smaller given problem to a bit of ambiguity in a smaller module, then to some more ambiguity in a bigger um, system that
mm,
you have no idea on how this is even going to work.
mm,
So it's a step by step process where yeah, you being fresh out of college, you will still go through um, the steps where someone senior will tell you that you need to do the coding for this. So you
mhm,
basically do the coding steps and then learn a little bit about the systems, and then eventually we get more confidence in you, and then we would say okay, fine, you go ahead and talk to such and such team and figure out what needs to be done.
mm,
So that's that's when you get into the bigger systems and how these systems work.
I see. Do you have any just career for people, for new graduates? Some advice or
um,
anything?
I would say I think you are pretty much on the right track by understanding. Some of the folks actually um, do struggle a lot with the LRU cache problem,
Mm,
and um, it's just that a lot of times people don't get into the coding specifics of things. So there are quite intermediate level people who struggle with these problems also.
mm,
Um, I would say learn about how some of the system designs work. I think there are few good books out there. Um, for example, would be, I mean, it wouldn't be at your level, but if someone has to ask you that how would you design Uber as in
mhm,
today, what are the various things you can think of? So when I'm asking you that question, I know you cannot design Uber in 45 minutes.
mhm,
And whatever solution you give them is neither right, it's not wrong. What I'm looking at is how you think. What are the use cases you can think of? What are
mm,
the different systems you are talking about,
mm,
right? If I have to tell you, can you design a chat bot for me, chat messengers, chatting room, or let's say that an online word documenting thing like the Google Doc.
mm,
What are the things that you can think of? Those are the areas that I'm looking for right now when you um, when I'm talking to a junior or an intermediate person, and
Mhm.
then I would ask you, maybe if I'm very specific, I can say, what are some of the numbers that you can think of? How much is the capacity that we can hit on this? How would you store? How would you design the database for this?
Mm.
Uh, so if you can only think of these, some of these questions, there are few. I would say I think there are YouTube videos and couple of questions. Even the LRU cache is a pretty common thing in a lot of design thing. This was a very basic. You can scale up the caching problem and think in terms of that. So, and the second problem that we did around strings, for that matter, think of it if it's a text search. Let's say I give you a dictionary of a lexicography, right? I
Mhm.
give you a bigger dictionary and then I ask you to find out the prefix, the common prefix in the first 100 pages of the dictionary. So if it's a real
Mhm.
world problem, how would you scale that? How would you create a service or APIs? Things like that.
Mhm.
Yeah.
Is studying system design actually useful for something other than interviews? Is it actually used on the job?
It is used on the job.
Okay.
Yeah, it is used on the job. So the cache, LRU cache is used on the job. The string
Okay.
search, yes, every project may not need it, but system designs are the ones that are actually used on the job.
Okay.
I'll give you one more example is if you do Google, when you do a Google search, you would see it starts giving you hints, right? That if you start typing in um, the latest version of Python. So when you
Mhm.
start typing in the latest version of, Google tries and interprets what would be your next word. So it gives you options, the latest version of C++, C Sharp, Java, Python. How
Mhm.
does it do that? What is it that how does that system work?
Mm.
Is something you can think of. It comes from a data structure. There is a data structure behind it. But what is that data structure?
Mhm.
And how do you manage that data structure are some of the things.
I see.
Yeah. So
Okay.
yeah, it's a fascinating world. Yeah.
All
All
right.
right. Any
Uh,
other questions?
no, that's about it. Thank you so much.
All right. Yeah. Have a wonderful rest of the day and a nice weekend. Bye bye.
Bye.